Look up. Go on, look at the night sky. What do you see? Points of light, ancient myths, a cold, empty void? For thousands of years, humans have asked one question that towers above all others. What is this place? What is the universe? Really? Is it just a massive machine running on clockwork laws? Is it a cosmic accident? Or is it something stranger, something conscious, or perhaps a simulation? Today, we aren't just looking through telescopes. We are going to combine the raw data of cosmology, the mind-bending math of quantum mechanics, and the deepest inquiries of philosophy to peel back the layers of reality. We're going to talk about the birth of time and the invisible dark forces. We'll explore the terrifying possibility that this universe isn't the only one. By the end of this video, you might not have the answer to why we are here, but you will know exactly where here is. What is the universe really? Let's start with the foundation. If you ask a scientist today how the universe began, they'll point to the Big Bang theory. But here is the first thing we need to correct. The Big Bang wasn't an explosion in space. It was an explosion of space. Imagine a balloon inflating. The galaxies aren't flying through the air away from a center point. They are painted on the rubber, and the rubber itself is stretching. This all started about 13.8 billion years ago. In a fraction of a second, inflation happened. The universe doubled in size, faster than light. Now, you might ask, how do we know this? True, but we have a smoking gun. It's called the cosmic microwave background radiation, or CMB. It's a faint glow that permeates every inch of the sky. It is literally the afterglow of the Big Bang, the cooled-down remnant of the early universe's heat. This map matches our theoretical predictions with terrifying accuracy. The Big Bang is currently the heavyweight champion of cosmology. But it's not the only fighter in the ring. Over the years, we've had the steady-state theory, claiming the universe was eternal and unchanging. We've had cyclic models suggesting the universe breathes, expanding, crunching, and bouncing back again and again. While these are mathematically elegant, none of them fit the data as perfectly as the Big Bang. So, for now, we operate on the assumption that we live in an expanding, cooling bubble that popped into existence 13.8 billion years ago. But what lies beyond that bubble? Is space truly infinite, or does it loop back on itself? And what about the dark matter? It's the invisible scaffolding of our universe, yet we can't see it, touch it, or measure it directly. Every answer we find seems to uncover 10 more questions. The more we learn, the more we realize how little we know. We are just a tiny part of this grand cosmic story, living in a moment of time that is barely a blink. So keep looking up. The universe is waiting to be understood. Okay, so we have a container, the universe. But what is the container made of? Enter Albert Einstein. Before him, we thought space and time were just a stage where events happened. Einstein showed us that the stage is actually an actor. He called it space-time. Mass tells space how to curve, and space tells mass how to move. That's what gravity is. It's not a magical force pulling you down. You are just sliding along the curvature of space-time created by the Earth. This theory, general relativity, works perfectly for big things: stars, black holes, galaxies. But if you zoom in, way in, space-time starts to unravel. Welcome to the quantum realm. Down here, the rules of common sense do not apply. In the world of quantum mechanics, particles don't have definite positions. They exist in a superposition, a cloud of probabilities. They can be in two places at once. They can be entangled, affecting each other instantly across vast distances, faster than light. Here is the biggest problem in physics today. We have two rulebooks: general relativity for the big stuff and quantum mechanics for the small stuff. Both are incredibly accurate, but if you try to combine them mathematically, the equations break. They yield infinity. They scream at us. This tells us something profound. Our understanding of the universe is fundamentally incomplete. We are missing a piece of the puzzle. A theory of everything that unites gravity and the quantum world. String theory is one candidate, suggesting everything is made of vibrating strings. But until we solve this, we don't fully know what reality is. Now, let me make it worse. Everything we know is only 5% of the universe. The other 95%, We call it the dark sector. It consists of dark matter and dark energy. And to be honest, dark is just a nice way of saying we have no idea what this is, but it's invisible. Dark matter makes up 27%. We know it's there because galaxies spin too fast. Without it, they would fly apart. There has to be an invisible scaffold holding them together. That's dark matter. Then there is the big boss, dark energy. This makes up a whopping 68% of everything. In 1998, astronomers discovered the expansion isn't slowing down, it's accelerating. Something is pushing space apart. We call this repulsive force dark energy. Think about that. The vast majority of reality, 95%, is completely invisible to us. We are just the foam floating on a deep, dark ocean. We don't know if dark matter is a particle or if dark energy is a field. We are living in a mystery novel where we haven't even met the main characters yet. The multiverse and many worlds. Now, let's get a little metaphysical. We've established that our universe is a weird place. But what if it's not the only place? Recall that inflation I mentioned, the rapid expansion at the start of the Big Bang. Some theories suggest that inflation never really stops. It stops in some places, like our universe, allowing stars to form. But elsewhere, it keeps going, spawning other pocket universes forever. This is the eternal inflation theory. Then there is quantum mechanics again. Remember the superposition where a particle can be in two states at once? When we measure it, it collapses into one state, but the many worlds interpretation says, no, it doesn't collapse. It says both outcomes happen. The universe splits. In one timeline, the particle is here. In another, it's there. If this is true, there are infinite versions of you. In one universe, you clicked away from this video. Bad choice, by the way. In another, you're an astronaut. Critics say this violates the principle of simplicity. Why invent infinite universes just to explain a particle? But mathematically, it holds up. It avoids the problem of collapsing wave functions entirely. This leads us to the anthropic principle. Why is our universe so perfect for life? If gravity were slightly stronger, stars would burn out instantly. Slightly weaker, stars wouldn't form at all. Is it luck, divine design, or is it a multiverse? If there are infinite universes with different settings, then of course we find ourselves in the one that supports life, because we couldn't exist in the others to observe them. We are the winners of a cosmic lottery we didn't know we were playing. Consciousness and meaning. This brings us to the weirdest part of the universe, the part that is looking at the screen right now. You. What role does consciousness play in all this? Standard science says consciousness is just a byproduct, something that emerges when you arrange carbon and water in a complex way. But some argue that consciousness might be fundamental, that it doesn't just arise from matter, but that matter might arise from it, or at least that they are linked. There is a concept called panpsychism, which suggests that some form of consciousness is woven into the fabric of the universe itself. And then there is the observer effect in quantum mechanics. Reality seems to behave differently depending on how we interact with it. Think about this. The universe is 13.8 billion years old. For most of that time, it was hot gas, rocks, and light. Unconscious, unaware. But then, the universe grew complex enough to create a brain. It created eyes. It created us. We are not separate from the universe. We are made of star stuff. We are the universe, waking up. We are the universe asking itself, what am I? As the physicist Steven Weinberg said, the universe seems indifferent to us. It doesn't care if we live or die. And yet, this indifferent machinery produced beings capable of love, art, and curiosity. It's important to remember that our picture of reality is always changing. For centuries, we've looked up and seen something different every time. In ancient times, we thought Earth was the center of everything, surrounded by crystal spheres, a perfect, unchanging system. Then Copernicus moved the Earth, and Newton gave us the math to understand gravity, the invisible thread holding it all together. Then thermodynamics taught us the universe is dying, moving from order to disorder, a slow fade into the cold. In the 20th century, Hubble showed us the universe isn't static. It's expanding, stretching out in every direction. And now we are grappling with dark energy and the mind-bending possibility of the multiverse, concepts that challenge everything we know. The point is, history shows us that our view of reality is never finished. It is progressively refined. Every generation thinks they have the answer. And every generation is wrong. We are likely no exception. So, let's try to answer the question, what is the universe really? It depends on how you look at it. To understand what this place is, we have to look through multiple lenses at once. Scientifically, it is a 13.8 billion-year-old expanding bubble of spacetime, ruled by the laws of relativity and quantum mechanics. It's mostly made of invisible dark energy, populated by a trace amount of matter that has organized itself into the galaxies we see. Philosophically, it is a system that seems terrifyingly fine-tuned for complexity. It's a machine that generates information. Existentially, it is a paradox. It is a place that requires no purpose to exist, yet it produced beings, us, who are obsessed with finding purpose. We are stuck with mysteries. We don't know why there is something rather than nothing. We don't know what dark matter is. But maybe the uncertainty is the point. Maybe the mystery is what keeps us moving forward, searching for the light in the dark. Einstein said, "The most incomprehensible thing about the universe is that it is comprehensible. It's a miracle that we can understand it at all." The fact that we, tiny apes on a wet rock, can use math to understand the birth of time, that is a miracle. The universe is a self-knowing system. So, what is the universe? It is a story that began in fire, evolved into shadow, and eventually woke up. And the best part? We are the ones writing the next chapter. We are the universe experiencing itself through our own eyes. If you want to keep exploring these mysteries with us, make sure to click that subscribe button. We have a lot more reality to unravel. What do you think? Is consciousness fundamental or just an accident? Are we alone? Let me know in the comments below. Thanks for watching, and keep looking up. The stars are waiting.